Another sample problem. You are boiling pasta and absent-mindedly grab a copper stirring spoon rather than your wooden spoon. The copper spoon has a 30 millimeter by 1.2 millimeter rectangular cross-section, and the distance from the boiling water to your 35 degrees Celsius hand is 18 centimeters. How long does it take the spoon to transfer 40 joules of energy to your hand? All right, this is conduction again. Conduction, the rate at which the energy transfers or flows from one location to the other, is equal to K, the thermal conductivity, times A over L, A being the cross-sectional area, L being the distance the energy is transferring from one location to the other. So here, from the water to your hand, delta T is the difference in temperature between those two locations. So we can find the rate at which the heat flows. If I come to the test notes, we are using a copper spoon. So copper is 400 watts per meters times Kelvin. The cross-sectional area, they tell us, is 30 millimeters by 1.2 millimeters, which we do, we do want to convert these to meters. All over L, well, the distance the energy is traveling from the boiling water to our hand is 18 centimeters, which we want in meters. The difference in temperature. We know our hand is 35 degrees Celsius. Boiling water is 100 degrees Celsius. So if we take the higher temperature minus the lower temperature, that difference in Celsius will be the same as the difference in Kelvin. So dq dt, the rate at which this energy is transferred, making the calculations here. 5.2 watts or 5.2 joules per second. So to answer the actual question, it wants to know how long, so how much time is it going to take for the spoon to transfer 40 joules of energy to your hand? So we essentially are saying we have 40 joules, and we want to know the time. The 40 joules divided by the 5.2 joules per second is going to tell us how much time it takes. The seconds will come out to be our units. So 40 divided by 5.2, 7.7 seconds would be the time.